Right, so that's a bit of 24mm diameter bar stock. We've got to bring that down to 22, so we'll take just shy of a millimetre off the radius. Get a bit of vibration out of that. Let's stick a center in that quickly. That is shocking steel. We might try and see if we can find another bit of stock. That's that's really crap. Righto, well I've changed the stock out, I've just machined it down, but that's machining an awful lot better. Sometimes you think maybe it's the tooling, maybe it's just you, but sometimes it's just the material you've got, and yeah, that stuff was pretty shocking. Right, we'll get down to the final cuts on this now. Yep, 0.04 to go. Right, so just off camera, I've just licked that face up there. Certainly makes a difference with a new tipping. Hopefully that's just shine. Yep, we can just lap that down to suit then. Alright, I might just quickly try that bush set on there and just see how that's feeling. It's in the crank. Alright, so that's just a little bit too firm for me, both ways. So that's exactly what I wanted. So what's happened is these have crimped in just very, very slightly, and just allowing that to be a little bit too tight on there. That's pretty much plumb on size, I think. Let's have a quick look. Yeah, that's pretty much dead nuts on size there. Let's have a look at this one here. 0.025. That's great too. I'm going to leave them at that. What we'll do now is we'll set up for our M8 threading here now. So I'm actually going to cut that in the lathe. And then we'll lap these down and get everything to fit up nice before we part off and then start doing the work for the oil holes and the socketed cap screw caps that we want to put in there as well. Alright, let's get this 8mm done. Right, I'll tidy that up. I'm just going to cut a little undercut in there for a thread run out. I'll drill and tap it. Sorry, I'll countersink it, and I'll put a half dead center in there, and then we'll bring you back when we're ready to start our thread cutting. Righto guys, we'll start cutting the threads. So I've squared the face of that up against the chuck jaw to get that nice and square. I'm using a bit of nickel paste anti-seize in here. Years ago we used to use the copper grease compound that we used to use, so that you try not to weld your tip in your dead center into your center. I'm using a half center here at the moment, half dead center at the moment, to give me the clearance that I need for the tool. So I've done a pre-scratch already, and I'm at 1.25, so I'm happy about that. We've got to go around about 0.76 millimeters deep. So I'm just going to use the Tap Magic as a lubricant. It's nice and clear. I was going to use the black stuff, but the problem with the black stuff is because I've got very little room to work with here, it tends to hide everything, and I can't see where I'm at. So, right, let's make a start. I'm just going to take this really slow, guys. So I'm only using the foot brake to stop. Alright, well I'll continue on with that. I might have mentioned in my previous videos that I tend to plunge cut, and then I will side cut using the top slide just to take a little bit off the flanks, just to tidy it up, rather than coming in at the 30-degree compound angle. Just the way I like to cut the threads. Alright, well I'll continue on with that, and we'll bring you back when we're getting close to it. Right, so about 0.1 of a mil to go. Just creep up on it very slowly. I could set up and use the star wheel on the lead screw to select my point to come in with the half nuts. But because I haven't got a lot of room that I'm working with here, I'm going to get down below where the clearance is. By the time the half nut's engaged and grab in, it tends to pull rather quickly. So I'm leaving it engaged full time to get this one done. I'm going to come forward a little bit well. Just clear the nose a bit. It's all very tight, this thing. I'm just going to go and get a nut and see how close we're getting. I reckon that might do it. Let's have a look. Yeah, it's soft enough now. I'm happy with that. That's quite firm actually, and that's just the way that I really want this. It's going all the way. It's actually going to nip down on that shoulder there when we're done. Alright, what I'll do now is I'm just going to 45 that off. I'll clean the threads up and we'll buff these back until they're a nice fit on the bushes, and I'm going to check that fit in the crank disc. Alright, I'll bring you back when we've sort of got something else to look at. Alright guys, we'll have a go at putting things together. We'll give it a bit of a dry run. I've buffed everything up and I've got all the individual bits fitting now. So we'll pop our crank arm on first. That's probably a bit too tight a fit, I reckon. I'll take a little bit more off that, I think. Alright, so that's the crank arm on, and that's the orientation of the pin. Let's pop the crank disc on. We'll see if it binds up on the bushes. Try and do this with the camera around. It's a bit awkward, but we'll get there. Righto. So let's spin that right up. That's it up tight. That's not too bad actually. I probably want a little bit more clearance on that, I reckon. But it's going well. Fits on nicely on the dowel hole and fits nicely on the thread as well. But that I think is just a little bit too tight, so oops. I'll give that a little bit more of a buff up. Alright guys, we've got that locked up nice and tight now, and that is just the sort of fit I wanted. That's beautiful, that will wear in. Now on the faces of this derrick, I tried to just take that a little bit of a buff. It's a little bit scratchy, and tried with a file and it made a pretty nasty scratchy surface. Bit of emery was the same, but I tried it with an oil stone, and geez, what a difference. It's come up with a beautiful finish just using the oil stone. It's flattened it out beautifully as well. So there's just the tiniest little bit of shake in that. There's virtually nothing in that. So I think we'll call that one done for the lathe. I'll part this off and we'll turn it around, and we'll start doing the oil ways and the recess for the oil button, and also for the socket cap screw that we're going to modify to fit in there as well, so that we can screw this into place. Alright guys, we'll bring you back when we're getting close to that. How about that? Ooh, that's hot. All the way through. Alright, I'll set that one in the collets, and we'll start working back from the other end. Alright guys, see you soon. Alright guys, that's our pivot pin. This is the little oiler that I need to fit up inside it. I want to machine the length back on this by about 1/2 millimetre. I want to try and get as much envelope space in here that I possibly can away from the oil hole. So I'm just going to nip a little bit off that. So we'll set that up in the collet here. Imagine trying to do this in a 3-jaw chuck. How that would work out. Take the whole thing out to get it out. Oh, don't drop it. Alright, so we've nipped that back just before it actually hits the spring, so I wouldn't want to come back any further than that. So yeah, very happy with that. That's reduced that back a bit. Right, we'll get the pin set up and we'll start the machining operations on the other end. Let's just face this off to 3mm. Right, let's set up for the drilling and boring. Right, let's go through with a 4.5 drill first. Yep, I'm going to go and give that a grind. Right. Let's try it this time. That was shocking the way that was drilling. I wasn't sure how well it drilled. I was sitting there looking at the gauge while I was drilling that in, but alright. Right, I had a look twice there. It's actually an M8 socket header cap screw. I've got a machine down to fit in the inside of that, not an M6. I'll slip up on my drawing. That's unusual for me, isn't it? Right, let's have a look at this bloke. That was a 9.5. And we'll go in with a 2mm slot drill. What I think I'll do now, it's better to see in there for you guys, but I'm going to open the bottom of that hole up to be able to fit that little oiler into place. So I don't have a 5mm reamer, so I've got some number drills there. So we'll creep up on it with those until we get a reasonably neat fit for that. So I'm just going to have a play around with that until we get that right. Right, so I've got an end mill now that I'm just going to do the final sizing with for that oil. Alright, all done, we'll leave it at that. Right, we'll continue doing our drilling for our oil hole into the cross hole. So I'll set up. Right, so we've got a 3mm drill. We'll set up for the cross hole, or for the pilot hole, and we'll do the cross hole in the mill. Righto, all done for here at the moment, so we're going to set up over in the mill and get that cross. Righto guys, we're going to make up this little hexagon insert, or socket cap screw insert. It's going to be out of an M8, not an M6. Just measured the bore in there, and it's actually 10.3 millimeters, which isn't going to hurt us at all. And it's going to be about 4 mil wide. So the plan is I'll make this a very light press fit or push in fit, and we'll lock that in with a 680. Make sure it doesn't move. So I'll just use these half bore gauges. These are great if you're trying to measure back into counter bores, small counter bores. I've just got that so that it's a nice sliding fit. And I've measured that at 10.3, so that's what we're going to machine our head down to. Alright, to move the camera out of the way, I'm going to part that off now, and then we'll flip it round and we'll just face the back off so we get it back to 4 mil thick. So I'll do that now. Thought I'd better film this. Normally with these particular parting off tools I smash them to pieces. But look at that, eh? Yeah. Particularly on a grade 8, well they're actually grade 12 6s, those Umbracos. Very, very tough, but I went through like a dream. Righto, I won't pick it up with my fingers because I'm going to burn myself, but I'll wait till that cools down. We'll set it up in the collet and we'll face it back to length, and yeah, get ready to put it in. So back again, I don't know what happened there, the camera's turned off, but so I've just figured it down with a center drill with a 2 mil tip on it, and I'm going to swap that out now for a 2 mil drill and see how we go with this cross porting. Alright guys, once again I'm using the collet chuck for this. With these smaller drills, I think using the drill chuck there's going to be too much wobble in it. I want to make sure this thing stays dead stable while we get it through this portal. Right. Alright, throw into the port. All through. So that's it all cross drilled. Right, I'll get that all deburred now, and we'll get ready to put the little brass oil button in there, and then we'll press in the hex drive. Alright guys, so I've pressed in the little oiler, as you can see, and it's gone in dead flush, and I've probably got about 5 to 10 thou that I've just got to machine off, which is exactly what I was looking for the hex drive. So I'll let the Loctite go off. It was a 680 I put on that. I'll let that go off. We'll machine that back flush, and that is the pin finished. All done. Alright, I'll see you soon guys. Alright guys, we've got this all fitted up now, and I'm really happy with the way this has come together. It's nice and firm, which is exactly what I was looking for. Nipped up. When we do nip it up, we've still got very easy rotary motion on that. So it worked out beautifully, and the oiler works really, really well as well. So you can see that in there. But yeah, I did a couple of checks on that, pumped it full of oil, split it, and yeah, the oil's gone right through it. So it's worked out really, really well. Really nice action. So very happy with that. One thing I might change with the design, and I was thinking about it when I was putting this together in Inventor, was that getting the crank in and out through the slot, I may have to open up a slot a little bit further to be able to take the bushes through with it. But it's the sort of thing, how many times I'm going to pull that apart and ever work on it. So I'll have a think about it. I may do it, I may not. It just means that the right hand slide's just got to come off each time you may want to get this this crank on and off. Obviously the idea is that we can remove the pin through that portal hole that we've put in there, rotate the crank around and then reinsert the pin in a new position to change the stroke without having to strip anything down. But if I ever need to get the crank out, as I said, I'll just have to take one of the slides off. But we'll have a think about it. But in the meantime, I'm very, very happy with that. And there's the reminder one. Yeah, nice little sawtooth on there. My wife thought it looked very artistic. Yeah, righto. Okay, all right. What we might do next is actually assemble this into the slide, and we'll see how everything fits up and what our clearances are like, and see if they come out as expected. All right, guys. I'll catch you soon. Righto guys, I thought we might go back and have a look at where we've been with some of this before we assemble it up. Here we can see the worm wheel housing without the worm wheel mounted. You can see it just on the right there. And this is what slips into the back of the main housing with the worm wheel in place as a cartridge assembly, just to make life a little bit easier. You can see here this is the worm wheel now attached onto that worm wheel housing, and that's ready to slot into the main housing and ready to install. And here we can see the cam disc has now been attached onto that worm wheel. The cam disc is finally attached or assembled once the worm wheel housing is in place, because we can't get it through the back area there. We can certainly fit it on with the actual worm wheel. Alright, this is the worm wheel housing and the worm now in place and attached onto the housing, ready to receive the cam disc. Just showing that worm wheel housing bolted up into the back of the main housing. This is where, well, the back end here is where it's installed through with the worm wheel in place. The crank disc is now attached onto the main worm wheel. As you can see, those 3 socket-headed cap screws, and that's now locked down in place, ready to receive the crank arm. Although the crank arm's now been attached with the crank arm pin that we've machined off through the bushes, and you can see it how it fits into that gap that we've milled out of the housing, and the same gap as in the slide that is there, but is currently removed to allow that crank arm to fit up. Right, we can see that slideway is now intact. As you can see, I've got dowels fitted to that, so in the future, if it ever needs to come off, it will go back exactly the same way as it was machined in situ, and relieved to see that the crank arm clears that quite nicely as well. Just showing the clearance of that crank arm through the slot, and it's even from the back end to the front end, so it looks exactly as per the design. Right overview, just showing the slide plate coming down over the crank pin, and we've got about a 1/2 mm clearance on there, which has worked out beautifully. I do have one issue in that when I go into the short stroke slot, the hole that I've got up there, the portal hole to access the crank pin, doesn't quite line up. I did make a change on the drawing, and I'm going to have to elongate that hole slightly to allow me to get access to that pin. Alright guys, that's the assembly so far, and that crank obviously it's not guided, but gives you a bit of an idea how that's going to work. So far everything's clearing. That crank pin Just cleared the back plate by, just on 1/2 millimetre. So we lost that 1/2 millimetre on the slides when the tool dropped out, and we've compensated for that on that crank arm assembly. It's certainly made a difference. All right. The next thing I think we're going to make up will be the ram, and we can start getting some connection points done in for this big end on crank arm, and start looking at the shear pin assembly on that. All right, guys. We'll see you next time round.